Hello everyone. Today I am going to discuss about fundamental law of electrostatics, Coulomb's law of electrostatics, right? Coulomb's law of electrostatics. We know that the force between two charges may be attractive or repulsive is the electrostatic force, and this force of attraction depends on the charges, magnitude of the charges and the distance between the charges, right? So Coulomb's law, according to Coulomb's law of electrostatics, the electrostatic force between the two charges is directly proportional to the product of their magnitude of the charges and inversely proportional to the square of their distance between them, right? Suppose দুটা চার্জ আছে পজিটিভ similar charge Q1 and Q2. So ইহঁতৰ মাজত যেটো ফোর্স হ'ব এই ফোর্সটো কি হ'ব ৰিপালসিভ। এই ফোর্সটোকে কি কয় ইলেক্ট্ৰোস্ট্যাটিক ফোর্স বুলি কয়। And the distance between the charges is suppose R. F is the repulsive electrostatic force between the charges Q1 and Q2, and R is the distance between them, right? Similarly, two unlike charges plus Q and minus Q, that is Q1 and Q2, and the electrostatic force between them is attractive because they are dissimilar, right? So the force between them is attractive and the distance between them is supposed in R. ঠিক আছে, দুটা ড্রয়িং দেখাইছো। ফার্স্ট ড্রয়িংটোত Q1 and Q2 দুটা চার্জ আছে, সিমিলার চার্জ, পজিটিভ। সো ইহঁতৰ মাজত যেটো ইলেক্ট্ৰোস্ট্যাটিক ফোর্স হ'ব সেইটো হ'ব ৰিপালসিভ, ইটোৱে ইটোক ৰিপেল কৰিব, আৰু ফোর্স দুটাৰ চাৰ্জ দুটাৰ মাজৰ ডিসটেন্স কিমান R। এটা এই ফোর্সটো ডিপেন্ড কাৰ ওপৰত কৰিব, চাৰ্জ কিটাৰ ওপৰত আৰু ডিসটেন্সৰ ওপৰত। This force of attraction or repulsion, but the electrostatic force depends on the charges and the distance between them and the distance between the charges, right? So যদি দুটা dissimilar charge হয়, এটা পজিটিভ এটা নেগেটিভ, তেতিয়া সিহঁতৰ মাজত ফোর্সটো কি হ'ব অ্যাট্ৰাক্টিভ। সেই ফোর্সটো ইলেক্ট্ৰোস্ট্যাটিক ফোর্স আৰু সেই অ্যাট্ৰাক্টিভ সেই চাৰ্জৰ মাজত ডিসটেন্সটো R. Now the statement of Coulomb's law is the force of attraction by force between the charges, that is the electrostatic force between the two charges is directly proportional to the product of the charges and inversely and inversely proportional to the square of the distance, between them. This is the statement of Coulomb's law. The electrostatic force between the two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Right? Mathematically, F is proportional to Q1, Q2, and F is proportional to 1 by R square. Therefore, F proportional to Q1, Q2 by R square. Right? Q1, Q2 by R square, and F is equal to K, Q1, Q2 by R square. Where K is a proportionality constant called Coulomb's constant or Coulomb's law constant. Right? So here K is equal to 1 by 4 pi epsilon naught. What? And F is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. Where K is equal to 1 by 4 pi epsilon naught. Epsilon naught is the permittivity in free space. Permittivity in free space. Right? Q1, Q2. So AC2 law, NO2 Coulomb similarity আছে. Coulomb similar হয়. Newton's law of gravitation. Right? Newton's law of gravitation লগত similar হয়. So here K is a proportionality constant called Coulomb's law constant, and the value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. Where K is equal to 1 by 4 pi epsilon naught, and epsilon naught is the permittivity in free space, and the value of epsilon naught is 8.85 into 10 to the power minus 12. 10 to the power minus 12 right? Then to the power minus 12. Where K is Coulomb's law constant. constant, and its value is 9 into 10 to the power 9 Newton. SI unit of force is Newton. Distance assign it meter. Newton meter square per. Charge assign it Coulomb. Coulomb into Coulomb. Coulomb square. Right? The value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. And K is equal to 1 by 4 pi epsilon naught. Epsilon naught. Where epsilon naught is called permittivity. Permittivity in free space. Permittivity in free space, and its value is 8.85 into 10 to the power minus 12. What? 8.85 into 10 to the power minus 12. 10 to the power minus 12. It is a reciprocal. Therefore, you need to give about Coulomb square per Newton meter square. Right? ঠিক আছে? Since epsilon naught is the reciprocal of K, so therefore there is to unit. K is the unit, it will ulta hoy jabo. Etu reverse hoy jabe. এতিয়া আমি নতুন টার্ম দুটা পালো। ফার্স্ট টার্ম হল চার্জৰ SI ইউনিট কলো মই কুলম, CGS ইউনিট স্টেট কুলম, রাইট? K এটা কনস্ট্যান্ট পালো, কুলমস কনস্ট্যান্ট, ইয়ার ইউনিট গম পালো, ইয়ার ভ্যালু গম পালো, ইয়ার ডাইমেনশনাল ফর্মুলা আমাক লাগিব। এপসিলন নট পারমিটিভিটি ফ্রি স্পেস, এটো এটা কনস্ট্যান্ট বুলি কব পাৰি, আৰু তাৰ যেটো ভ্যালু গম পালো, ইউনিট গম পালো, তাৰো ডাইমেনশনাল ফর্মুলা লাগিব। Next, dimensional formula of charge, dimensional formula of Coulomb's law constant, and dimensional formula of permittivity in free space. Right? A symbol to ki koy epsilon naught, epsilon 0. Free space or karone not x. SI unit of charge Coulomb C CGS system centimeter gun second, CGS unit of charge state Coulomb. Number 3, dimensional formula. Dimensional formula of charge. এতিয়া আমি চার্জৰ ডাইমেনশনাল ফর্মুলা কেনেদৰে উলিয়াম? তোমালোকে এটা ডেফিনিশন জানা, ইলেক্ট্রিক কারেন্টৰ ডেফিনিশন জানা? since current is equal to P, current definition, rate of flow of charge through a conductor. So here current definition charge by time. Symbolically, current I, charge Q and time T. Symbol of current is I, symbol of charge is Q, and symbol of time is small letter T. So Q is equal to I T. So what is the SI unit of current? We know that the SI unit of current is ampere, which is Coulomb per second. Coulomb per second. Charge unit Coulomb, time unit second. But যেটো ampere first letter A, so হেতুৱে তাৰ dimensional formula হয় আৰু electric current তো dimensional formula কি ampere first letter কি A. And what is the dimensional formula of time? Capital T. Therefore AT is the dimensional formula of charge, right? Dimensional formula of current is A because the ampere is the unit of electric current. So ampere is to A first letter to hetu iat ahi ase. Then time is to dimension hetu hol T. So it is the dimensional formula of Q, right? Next, যেটো আমাৰ dimensional formula হবো হেতু হবো Coulomb's law constant or K dimensional formula. Dimensional formula of K. Dimensional formula of K. Since Coulomb's equation, force is equal to K Q1 Q2 by R square. Therefore, K is equal to F R square by Q1 Q2. Right? So, what is the SI unit of force? SI unit of force is Newton. R is distance. SI unit of distance is meter. And SI unit of charge is Coulomb into Coulomb square. So what is the dimensional formula of force? So force dimensional formula is M, F is equal to Ma. So L T to the power minus 2. Dimensional formula of force. Force F is equal to Ma, M or dimension M, capital M, and acceleration or dimension L T to the power minus 2. Right? And distance, what is the dimensional formula of distance? L. But here, distance is going to say, so L square. But charge dimension, Q1, the charge dimension, AT. Again, Q2, again, the charge dimension, again, AT. Therefore, dimension M, L cube, L into L square cube, T to the power minus 2, A minus 4, t to the power minus 4, and a to the power minus 2. Right? So m power 1, l power 3, t power minus 4, a power minus 2 is the dimensional formula of Coulomb's law constant. Right? Next, dimensional formula of epsilon naught. Dimensional formula of permittivity in free space. Dimensional formula of epsilon naught. Since k is equal to 1 by 4 pi epsilon naught, therefore epsilon naught is equal to 1 by k, reciprocal, but 4 pi has no dimension, right? So k. So what is the dimensional formula of k? This one, m l cube t to the power minus 4 a to the power minus 2. Therefore m minus 1, l minus 3, t to the power 4, a to the power 2. Right? M power minus 1, l power minus 3, t power 4, a power 2. So this one is the dimensional formula of epsilon naught. Epsilon naught. And m l cube e to the minus 4 e to the minus 2 is the dimensional formula of what? K. Coulomb's law constant. Right? এতিয়া next কথাটো হৈছে কি force scalar quantity না vector quantity. Force is a vector quantity. It has both magnitude and direction. Force or মান আৰু দিক দুইটাই আছে. So force is a vector quantity. Therefore force বল এটা ভেক্টৰ ৰাখি. ঠিক আছে? এতিয়া আমি যেটো ভেক্টৰ অলৰেডি 11 ত পাই আহিছো. Unit vector, position vector, displacement vector, right? Hey vector idea bilak amage yat lagibo. Since force is a vector quantity, it is better to write the Coulomb's equation in vector form. Jodi amar force eta vector quantity hoy, telole Coulomb's jitu force or equation ami ta vector form ot likhibo paru. Vector form ot likhibo lagibo. Karon vector idea completely amar etia ase. Ami 11 ot complete vector kori aisu. Right? So since force is a vector quantity, it is better to write the Coulomb's equation in vector form. But our unit vector idea, unit vector ta can represent kuru. Suppose a vector ki asile vector quantity represent koribo karone ami opor arrow sign diu, arrow mark diu aru he vector tur magnitude represent koribo karone ami modulus a diu and the direction to represent koribo karone eta কি দিও ভেক্টৰ দিও যাক কয় ইউনিট ভেক্টৰ n cap. So vector A is equal to modulus of vector A into unit vector. Modulus A n cap. N cap represents the direction of A vector and modulus of A represents the magnitude of A vector, right? So next topic is Coulomb's law in vector form. Coulomb's law in vector form. Suppose Q1 and Q2 are the two charges Q1 and Q2 separated by a distance r. The distance between them is r. এতিয়া আমি জানো যে যদি দুটা সিমিলার চার্জ হয় এটো হেতু কি কৰে রিপেল কৰে তো Q1 চার্জে কাক রিপেল কৰিব Q2 Q2 charge কাক রিপেল কৰিব Q1 so force repulsive force or electrostatic force on charge Q2 due to Q1 is F21, right? So F21 is the force on Q2 due to Q1. Similarly, force on Q1 due to Q2. Similarly, force on Q1 due to Q2 is F12. And since force is vector quantity, then F12 vector. Right? So, A to force, I mean, electrostatic force বুলি কওঁ আৰু সেই electrostatic force to repulsive হয় কাৰণ charge দুটা similar, positive. And R to কি distance between the two charges Q1 and Q. So the electrostatic force on charge Q2 due to Q1 is F21, right side is our force 2, and force on Q1 due to Q2 is F12, left side is our. But Q1 charge to Q2 charge to right side displace হবলে হলে A charge to কোনফালে displace হ'ব লাগিব towards Q1. So displacement vector, what? Displacement vector of Q1 towards Q2 is R12 vector. কি কলো যদি Q2 charge to a Q2 charge to right side displace right side যাবলগিয়া হৈছে force কোনে দিছে Q1 এ দিছে কি force F12 force কোনফালে যাব right side so তাতিয়া হলে Q1 charge to এটো ফলে ডিসপ্লেস হ'ব লাগিব এডাল ম্যাগনেট এই ম্যাগনেটটা যদি এফালে ডিসপ্লেস তেতিয়া হয় এফালে যাব right এটো নর্থ পোল এটো নর্থে রিপেল কৰিব so এটো যদি স্টেশনারি স্টেটত থাকে এটো যদি মোশনত থাকে ডিসপ্লেসমেন্ট হয় তাহলে এফালে যাব বুঝি পাইছে কথাটো সিমিলারলি A charge to ফলে ডিসপ্লেস হ'ব লাগিব তেতিয়া চার্জ টু রাইট সাইডে ফোর্স পাব so displacement vector of Q1 is R12 which is along F21 vector, right? Next, the displacement vector of Q2 towards Q1. Similarly, Q1 charge to left sided get to displace hobo lagibo force goise tale Q1 to left sided displace hobo lagibo so displacement vector of Q2 towards Q1 to ephale ahibo lagibo Q1 or phale so So displacement vector কি হ'ব r21 vector, right? ভালকৈ কথাটো চিন্তা কৰিছো। ঠিক আছে এতিয়া এই টপিকটো এই যে Coulomb's law in vector form হেতু মই নেক্সট ক্লাছত আকৌ ডিসকাস কৰি আছো ঠিক আছে সেশন 3 ডিসকাস কৰি আছো